Okay, so we'll talk about surface of revolution. So when I have a graph of a continuous function, I revolve it about a line. The surface of it is called the surface of revolution. So the surface of the revolved. It's sort of the outside, right? It's basically the surface area. Think about a frustum of a right circular cone and the surface area there. So if I have a look at that and it's right, so here's my height here, right? I have L is the slant height. I have two radii, the top radii and the bottom radii, and it turns out the surface area of this function is 2 pi r L, and r is the average of the two radii. Gets a little bit more interesting if I have a different type of function. So let's say I had a function that looked like this, and I was to revolve it. So it looks like this. Okay, I still have I have some r, but guess what this r here is? The function. Okay, I need to know my L, and it's changing, and it's just like arc length. So my little delta Li is my arc length, just like before. Change in x plus to change in y. Okay, so my little surface area of revolution right there, like this little piece here, that area, okay, is 2 pi Ri delta Li. Okay, so remember, an intermediate value theorem tells you that if you'll have some x value in an interval, and so that I can say that this r, this value of my radius here, value of a function, is the function at some x inside there. As long as we know, we can say that it lands between the two. So we're also going to use the mean value theorem like before, as we did in the arc length, which is going to tell us that our delta SI is 2 pi my r, and then my L, which was with the surface area, the arc length, so we're going to have that. So this tells me, in general, that if I was to have my surface of revolution, area of my surface of revolution is just going to be the integral 2 pi from a to b of f of x. That's there. Okay, I have 1 plus the derivative of x squared and the square root, and then dx. So this part's my arc length. That's my Li. So for a formal definition, I'm going to let y equal f of x to be a function. It has a continuous derivative. On my interval AB. And the area, I'm going to define it as S, of the surface of the revolution formed by revolving the graph of F about a horizontal or vertical axis is S equals 2 pi, integral from a to b, of r of x, square root of 1 plus f prime squared dx. And r of x is going to be the distance between the graph of f and the axis of revolution. And we could do the same if we had a function in y. It would be r of y, and this would be g of y dy. Same exact